So from the last example we can see there that the class intervals written here are representing the ages of the mothers, and the totals written here, they are the frequencies corresponding to the respective class intervals. So when you are writing these class intervals and these frequencies together, then it becomes the marginal frequency table of ages of mothers. Okay, you can see the frequencies and the class intervals here as compared to here. Okay, so there is a typo error here. It should be having 2. It has become 3 here. Rest of those are fine. Next, similarly, the frequency distribution of number of children, that is the discrete frequency distribution. Here are the x values and here is the frequency. So the total here is 20. So that is your marginal distribution of number of children, that is other variable y. Next, another example. The data given below relates to the height and weight of 20 persons. Construct a bivariate frequency table with class interval for height 115, 125 to 135 and the weight as 62, 64, 64 to 66, and write down the marginal distribution of x and y. So let us look at the data here. So this is the data. So serial number 20. So heights have been given and weights have been given. Okay, so let us look at the range of the height. So the lowest value here appears to be 117 and the highest value here appears to be 170 of these two tables. Similarly, the lowest value among the weight would be 63 and the highest value would be 71, which is not much of a difference, but we can write it in terms of class intervals. So height has been taken as the variable x and weight has been taken as the variable y. So depending upon the range, the number of class intervals here are 6 class intervals with a width of 10 each. So 115 to 125, 125 to 135, 135 to 145, 145 to 155, 155 to 165, 165 to 175. Similarly here, weight will be 62 to 64, 64 to 66, 66 to 68, 68 to 70, 70 to 72. Although there is not much difference between the lowest and the highest value here, but still, since the desired result is in form of a class interval, we are writing that in the form of a class interval. Okay, so let us look at how data is classified now. The first one is height is 170 and weight is 70. So let us look at where does it belong. So height is 170 here, 170, and the weight is 70 here. So 70, 170. So it corresponds to this cell. So you are striking a frequency here. Similarly, let us look at the second one, 135 and 65. So let us look at the cell which corresponds to the both the frequencies. One, so 135 and 65. So 135 lies here and 65 lies here. So one frequency has been striken here. One tally has been striken. Similarly, 136 and 65. So 136 lies here and 65 lies here. So this is the common cell here. So another tally is struck. Next, 137 and 64. So 137 lies here, 64 lies here. So one tally is stricken. 148 and 69. So 148 lies here and 69 lies here. So one tally is stricken here in this cell. 121, 63. So 121 lies here in this and 63 lies here. So cell corresponding to these two are this one. So one tally is stricken here. Similarly, 117 and 65. So 117 lies here and 65 lies here. So the common cell is this cell. So one tally is stricken here. 128, 70. So 128 is here and 70 is here. So one tally is stricken here. 143, 71. So 143 is here and 71 is here. So one tally is stricken here. 129 and 62. So 129 lies here and 62 lies here. So one tally is stricken here. 163 and 70. So 163 lies here and 70 lies here. Hence one tally is stricken here. Similarly, 139 and 67. 139, 67. So another tally is stricken here. 122, 63. 122, 63. So another tally is stricken here. 134, 68. So 134 and 68. So one tally is stricken here. 140 and 67. So 140 and 67. So it is stricken here. So if you write the corresponding uh, common frequencies with respect to their class intervals, so you will be getting this distribution. So you are counting the tallies and writing the total frequencies here, and then you are adding them horizontally as well as vertically. So horizontal addition gives you the frequencies of one variable x, and vertical addition gives you the frequencies of the other variable y. Okay. So here there are the totals 4, 5, 6, 3, 1, 1, and here 5, 3, 5, 4, 4 and 4. So the total here will be 20. And these are the marginal distributions. So this is the marginal distribution of height. That is this frequencies and these classes and these frequencies. And similarly, this is the marginal distribution of weight. That is these class intervals and this frequency. Both the totals here are 20 and 20 respectively. So this is the method of constructing a bivariate frequency distribution. So by applying the proper rules of classification, we are deciding whether the variable has class intervals or single values, and then we are writing the common frequencies and the marginal distributions.